Hey, what's up, guys? How's it going? Back here at the Python BACnet Stacks Playground. So we are just working a little bit more on Rust. Actually, we're kind of focusing a little bit on network programming in Rust. I'm actually troubleshooting right now in Open-FDD that it does not um, respond to a BACnet discovery. So, like Open-FDD, when it runs in the field, in the operations technology land, it'll come up as a BACnet device, and you can even the idea will be that it'll display like number of faults that it's detected in the HVAC system, and even potentially maybe we could even show some data to the control system network about weather data from the web. So we can do some cool things as a BACnet server, but I'm still troubleshooting why it's not showing up as a BACnet device. But I think I'm kind of making some headway, and that might come out on the next patch cycle. So I'm doing like daily Docker container updates for patches. So this will be coming out soon. It'll be 3.2.6. I'm just waiting for the GitHub Actions to package to package everything, to package the Docker containers, and then you can bootstrap it on the edge. Um, so yeah, so like what I use here is GitHub Actions publishes all of the documentation on the internet, and that'll also publish um, the Docker containers. So in the future, it'll be OpenFDD operating system way in the future. So maybe that'll be 2027 or something, and all the bugs will be worked out by then too. So what I'm doing today is actually Python Backend 6 Playground, different repositories. So like we're studying some of the how to do network programming. So we're studying how to do network programming in Rust. I mean, we did quite a bit in Python prior to this. So yeah, so we're gonna at the moment we're studying Rusty BACnet, Rusty Haystack, and then also some data modeling in Rust and RDF is coming way later. Maybe this by the fall we'll probably hit that. So we're gonna use a Rust library for that someday. So we're still like doing this day 28 onward. Socket IO, socket programming, Rust backend stack. So yeah, network programming at the moment, and we were talking about this yesterday. It's like a specialty for a type of software engineer that specializes in bits and bytes on the wire. So they create code that decodes messages, so computers can communicate. So that can be like Wi-Fi systems, BACnet stacks. Um, a lot of these people for BACnet, they specialize in making BACnet communications work, and they might not know much about HVAC, which HVAC control technician would know quite a bit about HVAC systems and HVAC sequencing, a little bit about BACnet, but the BACnet developer, they're a network programming specialty person. And then their niche would probably be operations technology protocols like Modbus, BACnet, Haystack is one we'll be using. So there's also other people that Wi-Fi or TCP protocols for Wi-Fi, the wide open web, or how video servers stream data. So that's it's kind of a important part of software engineering is not only like web apps, front end, back end, database, but network programming is also an important part. It's very challenging too. So we kind of focus quite a bit here, really, in the network programming field. Even though a lot of these applications are more they're applications in the network programming field. Like we use network stacks that are developed already. Thank God, because it's really hard, challenging to put together a network stack from the scratch. Um, So right now we're just focusing on Rust, BACnet, and Python BACnet. But there's other languages out there too. So okay, so like what we're kind of working on is we're going to do a little bit in the future for a do-it-yourself BACnet routing labs, just like test bench purposes on how to simulate a really messy, let's say there's a campus that has multiple vendors, and each vendor BACnet networks are on different UDP ports, which can make system integrator nightmares. We're going to try and simulate some of that stuff in the future. So today I want to work a little bit on the Rusty BACnet stack, show you what I'm doing with Open-FDD as an attempt to try and fix the drivers in Open-FDD, as I kind of dumb it down to just a really bare bones basic BACnet server, which we even did in the Python world previous to this. Check out some of the earlier YouTube videos we made, the Backpipes mini device we morphed it into a web weather application. So we scraped data from OpenWeatherMap API, and then we used that data from weather sensors, probably at some local airport weather station, to make that into a discoverable BACnet device. And now we can give the building automation system data from the web, which can be better than local building sensors for weather. Like outside air, dry bulb temperature sensors and building automation are known to be flimsy, cheap, often installed very poorly, and not nearly as quality as like a local airport weather station. So one of our apps was to get that data into BACnet as a BACnet server. I'm also setting that up as a fault rule tool that I can show you in the future. A lot of stuff coming. But just for today, it's a little bit about um, just getting into Rusty BACnet as a BACnet server. And then we'll end this on just like one of the theory lectures in Rust. Okay, and then we'll do a little bit someday with Project Haystack. And also, I want to play around with this concept idea as a do-it-yourself data lake, which is just it's just a SQL server running in the cloud. So SQL is a database, and then Postgres is just a flavor of SQL. So kind of like how Niagara building automation has many different flavors of the same tool, Workbench. So kind of think of it as that analogy. Okay, so let's look at this. Let's go. Our first vibe code app for the Rusty Haystack is to mimic what Open-FDD is doing. So Rusty Haystack, this is Justin's project. If you guys also have any questions, just jump over to the GitHub and look. Hey, there's Justin right there. So there I post, people post YouTube videos all the time for like the latest and greatest in AI. So a lot of good resources going on in here. There's also chat about anything, Open-FDD, AI chat, BACnet protocols, Niagara framework chat. Some people just ask for help. Mechanical things like fault detection, embedded systems, which is not much there yet, but we'll be talking about that soon. And then just general software engineering chats. So hop on the Discord channel, which you can find. It's around here somewhere. There's a button for it, right? Just click this button right here. Okay, so enough of the chit chat. Okay, so where were we? So we're gonna do an Open-FDD mimic. So this is what I have running today. So this is in Vibecode app 16. This is just the BACnet server running in Open-FDD. just with everything else stripped out. So Open-FDD is turning into a really big Rust project where it takes like an hour or two for it to even compile. So it's getting to be a big can of worms and Rust. So like I wanted to just strip out what I'm trying to troubleshoot for the BACnet server, and now I think I finally have it working. So like, let's see, I've been using Workbench quite a bit for doing my BACnet testing. So I just happen to have a copy of Workbench. I was using the BACnet Discoverer tool. Yabe is also another really good one to use. So Workbench is pretty cool if you have it. If you have the tool available and it's licensed, um, it is probably the best of the best. So like, I'm actually using it to test out this future and haystack server that I've running on here too. So Open-FDD can kind of work. We can work the bugs out of Open-FDD too. Okay, so like right at the moment, I have this is a JCI FEC and a BACnet server running. So this station, this is running on the same computer, the Windows computer I'm recording this YouTube video on. Just a normal generic Niagara station. And then these are BACnet points. So this is the same FEC. I think I've been telling you guys a little bit about this. This is just an FEC on my test bench. And you can even crank some of the actuators open. So if I go like this, drive the actuator, you guys probably can't hear this, but there's actually this, oops, don't have enough wire space, but there is actually an actuator motor moving right here. So if you see that down in the corner, there, that is an FEC. And I have a phone call. So that is my test bench. I can test on a real device. So like what I am doing right here is I'm trying to troubleshoot that Open-FDD is not coming up as a BACnet device, but I think I have it figured out. So I'm going to do a BACnet discovery in, whoops, that's a point discovery, which we also do in our code bases we study. So if I study this, do a global test, a global device. So right now Workbench is sending out who is BACnet request on my little test bench, and hey look, there's Open-FDD running right here. So we can pull Open-FDD into Workbench, and this is actually the Linux server running right here. This is my handy dandy little it's an old former Windows computer converted to Linux. It was kind of retired, so it's working perfectly as like a little test server. So this is where I've been doing all of my development work for Open-FDD. No, actually, I stripped that away from it too because it doesn't have enough RAM. So I have a bunch of issues where I can't compile a big Rust project very well on 8 gigs of RAM. So I'm doing that as well on my Windows computer in Windows subsystem for Linux. And then I'm pushing that to GitHub. And then I use GitHub Actions to publish containers. And then I'm using this computer right here to the next to me as to mimic like what people would do in the real world is they pull GitHub containers from GitHub Actions, and then I'm testing it, rigorously testing it daily with real BACnet devices, and just to get all the bugs worked out. I think it's kind of important that yeah, many patch cycles are going out. Just quite a bit's going into Open-FDD at the moment. So we finally got it to show up as a BACnet device. And what was kind of, yeah, look at this. There's no vendor, no model. So maybe we could ask Justin someday how to put rusty haystack. maybe we could even take a screenshot of this, and then I'll put that, look for this message on Discord to, hey Justin, how do we get this on a vendor and a model on Rusty Haystack? Because if you look at here, Backpipes shows up as a vendor, which is kind of cool. And it looks like there is even Open-FDD on there, and even says Open-FDD BACnet mimic. So like the AI agent must have put that in there programmatically. Cool. Okay, so like, and then we can even do a point discover in on the BACnet server running. So these will be like points that you'll be able to pull in from Open-FDD at some point in the future. I'm still working out a lot of the bugs, but someday this will be if faults are present. So you'll be able to dial into Open-FDD through a web browser and then really rigorously look at what the faults are going on there too. But then there'll also be like a building automation integration feature of Open-FDD where Open-FDD could be on the same LAN as any BACnet device, and we could even integrate it into the building automation system, and an alarm could populate or something. So we could put on the building automation system, we could even put an alarm on this. So like if I was a system integrator in Workbench, I would go find, I think there's an alarm, and then you would put an extension on here. So like a Boolean, I think this would be like a Boolean change of state in alarm. So you drag in an alarm, then you set it up to be, hey, there's an alarm present in Open-FDD, which would be, that's a fault detection alarm. So there'd be some more sophisticated fault detection rule has found some problem in the mechanical system that's written in SQL. So we'll get into all of that in a little bit later when I'm ready to show you guys that. And then we'll also be able to give the building automation system open weather map API weather data. So this will be web weather humidity, and web weather outside air dew point, which can be useful for free cooling purposes. So like to reduce mechanical cooling, electrical consumption. There can be some more sophisticated free cooling logic that looks at outdoor dew point and then dry bulb at the same time. So we'll do all that a little bit later. Okay, so like I do have Open-FDD functioning as a discoverable BACnet device, which means that the BACnet server is operating correctly. And then the next thing that we need to do is probably start looking at like a packet capture. So like we're going to take like a packet capture and then validate that there's no malformed BACnet traffic, or under the hood that Open-FDD isn't accidentally sending out like zillions and zillions. If it's doing this, like I'm clicking this button, discover, 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 discover. You know, if we were doing that on a live building automation system, like we'd be causing tons of like bad global traffic. You know, like I wish you guys could see my other screen because Workbench pops up these messages that a discover has went, you know, boom, 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 boom. You know, it creates tons of traffic, and like we want to be careful that in like the application is not, you know, pounding the BAS in any way, the live HVAC system. And then which we'll also get into in Open-FDD. It's like when we have a live HVAC system, is like we're not polling every point in the building automation system. Like an easy button would be to discover every point in the building automation system, map it, and poll it. And that's, you know, I think that's bad practice. because it creates a ton of redundant traffic, unnecessary BACnet traffic. And for fault detection purposes and alarming and HVAC health, we probably only need 15% of the points in the entire building automation system to determine that the HVAC system is generally working okay. So that's how we throttle the BACnet operation technology system manually by minimally setting up polling on bare minimum amount of points. And we'll get into all of that later. So I think I have enough to show you here. So like I'm actually gonna minimize Workbench. So this vibe code app 16, I use AI agents to create it. Basically, I think I should show you this too. So if I go back to, maybe I'll just duplicate this tab. So like what I did was I went to, so we did the mini device. So that was on the BACnet. That was on mini device was from Python world, from the backpipes. So that's a sample in Python world on the backpipes GitHub. And then I used AI agents to recreate that in Rust with the Rusty BACnet stack. And then Justin, he actually further enhanced it a little bit. So we have some more examples that are working. So Rust, if you go in here, more samples. These are more samples like that I'm testing at the moment that they are functional Open-FDD drivers. So in Open-FDD, like we'll use a BACnet write at some point in time to do algorithms to interact with the HVAC system. Mini device revisited, that is what came from backpipes, point discover, read multiple request, and then a whois. And one of these folders also goes into reading priority array. I think it does in the point discover program. So this is what I've been integrating into Open-FDD basically. So this is mini device. This is like a form of like what a Rust. Yeah, here we go. So it is a Rust conversion of the mini device.py on backpipe 3. I can't remember if we looked at this already, but it works. And Justin gave it his blessing before integrating it into the Rusty BACnet as a worthy example. So I further have enhanced this mini device into Open-FDD of the points that I just shown you that were the web weather, if faults are present. So that's where I was going with that. Sorry if that was kind of long-winded. Okay, so like let's just kind of look at this code that I showed you here. This is what I was saying, and it all stems from the backpipes 3 converted mini device into Rust version of that, and then morphed into a Rust version of what I need for Open-FDD to make the BACnet server possible, with 4 BACnet analog value points and then 2 BACnet binary values, and then one of these, this should be writable. This is actually a writable point, commandable optimization. I forgot to map that as a writable point, but okay, so let's just kind of glance at this code for a second, and then we'll end in our own Rust theory lecture for today. Okay, so here we are. This is the mini device code. So this is like still like pretty advanced code to look at. Let's just look at the cargo toml file. So it looks like the entry point is lib. All right, I still have to get used to some of these. So these are dependencies, BACnet client, so that's coming from Rusty BACnet. I have to see if this will clone okay the way it is, but it's pulling a few things from Rusty BACnet. A couple, this is Tokyo, I think it's pronounced. That is a Rust networking library, socket 2. So, okay, kind of cool. And then let's go into the source. Kind of check what these are looking like. I still have to get used to like looking at Rust projects. We'll get into this a little bit later. I just kind of wanted to poke around in here. There's a lib.rs, a config.rs, a network.rs database, server, probe, and a bin. At least this is what AI made for us. And it appears to be working. So like this stuff does kind of remind me a lot of coding in C. The C BACnet stack is really hard. So like we looked at this yesterday in our theory lecture for Rust, like what mutable is, the let command. So like we're creating a variable here, function. So yeah, we'll get into this a little bit later, but this is a working example of how what I'm doing to troubleshoot Open-FDD's BACnet server. This is asynchronous code here, so there's an await. Pretty cool. So like the code is a little more intimidating looking, and it should be more intimidating than Python. Python backpipes like hid a lot of stuff under the hood, and then especially back0 even further hides a lot of things under the hood. So like in 7 lines of code in back0, you can do an entire BACnet app, but there's a lot going on under the hood where like when we use these more systems level programming, a lot of the boilerplate code is there, and it's very raw and nasty looking a little bit, I think. Okay, so like this is working. I kind of like not a big fan of like how the files are laid out, but it is working. Anyways, so maybe we could just jump back to our Python vibe code app, our script lesson for today. Okay, so I think like we're up to day 30 if I'm not mistaken. Gosh, it kind of bugs me maybe just a little bit of like how the code looks. It's just sorry, I'm jumping around a whole bunch here, but like this Open-FDD mimic is yeah, it just looks kind of a little bit nasty, I think. It's hard to know like where the main entry point is. Maybe we can just study these type of code bases a little bit more. So, but this is the joy of network programming. Default NIC card. So this is Linux world. Anyways, okay, so maybe I can butter that up a little bit, but it is a working BACnet server, and then we'll get into we will also get into you know, just packet captures in a little bit. So like what, you know, let me see. So this what someday this will be a writable point for Open-FDD, this optimization enabled, where if we're running algorithms, which is a future concept, this could also be integrated into the building automation system, where if it's through BACnet, that the optimization is enabled, where they can, if it's algorithms are causing a problem, that the HVAC is that the maintenance department can BACnet override it off, and then we could pull this value into some Rust algorithm. But it is actually working. So if this was this isn't flagging any errors in Workbench, so we are doing a BACnet override value 8. So yeah, future algorithms, if Open-FDD optimization enabled BACnet point is BACnet overridden off, which it is right now, then the algorithm could go to some off state, release whatever you're doing, which could be demand response, it could be energy efficiency algorithms for duct static temperature, pressure, whatever we're doing some to the mechanical system. Okay, enough with this. Let's go into our theory lecture for today in Rust. VS Code. Get our SSH going to the Raspberry Pi, which is just another device on the test bench. It's just right over there. Okay, so we just have a main.rs. I think I might ask AI to rewrite the vibe code app 16 for the Open-FDD mimic, maybe with a main entry point, because it's laid out kind of nasty, I think. But then we can, talk about it in the future. Okay, so day 30 Rust if loop match. Goal: branch and iterate like Python if and for loops, but with match for exhaustive enum style logic. So it looks like this is a function in Rust, classifies a flyer temperature. So then with a function, we pass in a variable called SAT, it looks like. That's a floating precision point 64. And then it looks like Rust requires this little caret symbol, which I think like that C++, if I'm not mistaken, does something like that too. And there is this AND operator, where it looks like we're looking at the value of it, and then if else elf. If I'm not mistaken, I think these that character means something to in Rust. All right, so here's another one. Okay, so maybe copy this code. Let's see, what did we do yesterday? Okay, so it looked like it went. One compile warning. So Rust has this dead code, or this warning to ignore unused code. Okay, so I think like what it was doing, it was like, this is how you do a for loop in Rust. So in Python, it was for I in range, where we would do in brackets like this, 5, just put a 5 in the middle, but Rust you do for I in 0 dot dot. And then we have to do curly braces, like a C++ project or Java. And here's something let code equal to, so match. Interesting. So what this program did is that I iterated 5 times through here just to print the sample, and then it also did a match code 2 where it said should have print warning, which I think it did. So yep, I iterated 5 times starting at 0 to 4 and then printed warning. Control sequences are state machines. Match makes BACnet priorities, levels and alarms, severities. Explicit compiler warns if you forget a case. Mini examples: loop over these and print classify SAT for each. Use while to simulate 3 iteration poll loop. Oh boy. Okay, so how would we use a while loop? Write match. I don't even know how you do this in Rust. Might have to cheat and use Google. Alright, let's see if Google AI can do this. Okay, so this is Python. This is good experience. So these are our values. While. Cool. Python looking version. And then just say Rust versus Python. Then here's the Rust version. Cool. Few things that I get confused about is like, I think you have to use this, ask like what this character is. I can't remember. What is this character? In Rust it references to borrowing. Borrows a reference to the array without taking ownership. Okay. So this is kind of gets into referencing memory management manually. So it's kind of like something you have to do in C++ world, is you have to manually reference memory management purposes. Yeah, look, here is Rust memory management. And then it can also be bitwise operations. Like in Python, that just means and. Okay. Write match on a priority that prints out manual if it only sees priority 8. Okay, so gosh, these are a little harder than I thought it would be. So if we're doing the right match on a priority, so I think we do, if this was BACnet 1 through 16, then we could just modify this to be priority. So this is, I think in Rust, is it our comments are this? No, this. Comment priority 8. That's the manual override for the human in BACnet. Let's see, so I'm just going to copy this line. Coding in Rust is a little bit intimidating. Let's just say human override. Actually, I don't think I need this. Just gonna see if this works. Okay, we screwed something up. Nothing like Rust. Okay, so let's just work with this. Then I'm going to say sorry guys. In Rust, our lesson is, I could be using ChatGPT, but oh, you do have to do that. Okay. Alright, so I'm going to try and not cheat. Oops. Try not to cheat. Okay, so we got this part, 1 through 16. Print line, samples, I, let priority. Okay, so they moved this to the top. And then they did a dot dot 1 through 7. I'm not used to the syntax on this. Okay, with the pipe operator or 9 dot dot 16 in BACnet. Equals sign caret print line normal. Let's see, then they ended it with a, this must be stand for kind of just a generic equal sign this print line. I think they set unknown and with another comma. Okay, I did something wrong here. Nothing like doing all this manual the old-fashioned way. Okay, so what did it not like? Didn't like this. I think I'm missing an equal sign here. Gosh, this is really funny syntax. Still didn't like that. I am not seeing this. Okay, so if 8 is an A value of 8, that's a manual override. 1 through 7. Well, when in doubt. Well, that works. Something I was doing in that little subset of characters was wrong, but hey, there's nothing like learning on the fly. All right, right, so it's a little harder than Python. I'm kind of feeling that already. The pain. Okay, let's do vibe code app 2. Okay, so convert a Python style for X in list. Mental model. Wow, these are challenging. So like, as you can see, this is perfect for what I need right now. So convert a Python style for X in list. Mental model, what is 0 dot dot versus 0 equal 3? Ooh, okay. So I guess in Python, we would just be doing like data equals a list. And then we would just do for I in data, print data. Like that's how easy Python is, but how to do this in Rust? I think we could just say, gosh, what did our, usually it's supposed to say how to do that in the examples, but it didn't give us an example. So, oh, okay, so here, yeah, it did. So loop over this, classify, well, say in Rust, how to do that. Okay, option 1, borrowing, the most common. If you want to print the entire array multiple times, you must borrow the array from data. Option 2, printing individual items. Asking us what is the entire code base? Where is data 1, 2, 3 defined in the all right, let's use ChatGPT. How to define in Rust data is an array of 1, 2, and 3. Here we go. That's what I'm looking for. I guess you just have to describe it as let. Just we'll put that on inside of here. For I in data, the operand, curly brackets, print line, so they do colon I. Gosh, I wish I could have a little bit more of a Rust from the very beginning. Just on the syntax of all this. Could not be compiled. that work? Okay, I think I get the gist. I was doing this right here and not right here. All right, so what was our original task? Kind of fumbling through this, guys. I'm sorry if it's kind of dry. Convert Python style for action to mental model. Okay, so we did this. Okay, what is the difference? I think it's this if it would equal. I'm just gonna ask ChatGPT to see if I have that right. Okay, 0, 3 here means 0, 1, 2, 3, 3 times. This means start with 0 and include the 3. Oh, okay. Cool, I did not know that. That's why it's... All right, the fire hose is deep. This is all good stuff. I have a feeling it's going to get really deep when we start doing network programming and Wireshark. We're going to immediately jump into some really advanced topics. So the fire hose is deep. Okay. Refactor nested if to match if on one of the small enums you define. Oh boy. Okay, so I think we could do, we can kind of look at this example. I think in JavaScript there's a match. Also in C, I know there's a match too. So we could do, in Python this is so much easier. Nested into match. Okay, so I'm just gonna steal this. Oh, I'm just debating. So maybe we could just do, this is gonna cheat. If I equals 2, I know it's not an enum. I think this would work. I'm gonna have to do this. Print line 2 is found. That's my error out. Alright, it didn't like that. Ooh, I think I know. Gosh, if you do operators in C++, I think you have to do like this and then do another set of curly brackets around here. Okay, I think that actually worked. Here, oh no, it cannot compile. Okay, so let's just close out of this, and as you can see, the learning is steep. Oh, okay, so we just needed this little operand. Very close. 2 Rust fixes. I is a reference because you used and data, so compared. And 2 is dereference. Print line needs I. Okay, so so I guess the mental main thing for me is you use this operand to reference something in the array, and then you have to do the same thing down here too. If the value through the loop, we want it to equal the 2, then you need this operand symbol. You don't need to do that in Python. You could just do if I equals 2. You don't need the operand. Ugh. Okay, so this is I just want to see like what this would look like. And then we'll call it a day. Key takeaway: matches your friend for BACnet enums, object types, error codes later in Rusty BACnet labs. Cool. Okay, so I just wanted to ask ChatGPT what it would do. Okay, so we would have to define an enum. This would be really good for me to type out manually. So when I do things, do I have the time for this? Maybe I will just attempt to do this and look at this on two screens. Sorry guys if this is kind of ridiculous going on here, but it's kind of, I need to learn Rust. So there's no better way than, for me at least, to, some other people do this too if they learn a coding language, is to, you know, kind of type out and don't copy paste. So I'm going to try. So you have to define the enums, the enumerated values, and then define a function. I'm just going to change these names. So looks like we have to declare the values you pass in there. Num check, curly brackets, if n equals 2, num check tab complete 2. This reminds me of C++. I've done a teeny bit of JavaScript and C++ tutorials. Whoops. Okay, then this is our main function. Function main. Curly bracket this. Let data equal 1, 2, 3. Okay, so these are these loops that with the operand I in data print line exclamation. Gosh, that syntax is so funny in Rust. But it does have kind of like a similar flavor to, I think, like C++, JavaScript kind of have this stuff that's kind of similar. Okay, so then now we do our match, classify, I, pass that in, curly breaks as num check. Is found. Another semicolon. Num check. Gosh, that's just such like a weird mix of like JavaScript, C, and C++. No thing. Okay, so what I'm missing here is something's going to error out because there's There's 4 of these guys. So check this one. Oh, I get it. So this is like, this is down here. See if we can format this document. Formatter. Oh, I don't have a formatter for Rust. So I guess we could just tab this over, I think. If this doesn't work, I'm just going to copy paste. Still didn't like that. All right, semicolon, semicolon. Anyways, I think I'm all out of time, guys. I'm just gonna have to copy and paste, but at least we did it the old-fashioned way to try and learn a few things. So sorry if this video is kind of long and exhausting. I'm all out of time, and so this will be kind of the style is probably watching me fumble quite a bit with Rust, and then hey, I'm learned a few things. So like eventually what we want to get into is how to troubleshoot network programming. So we're going to get deep into the weeds, and there's a lot of hard concepts, I think, to accomplish. But bottom line is like, well, we'll learn something cool. Thanks for watching me fumble through this, and I'll see you tomorrow.